Welcome to Logical and Assignment Operators. There's a couple of things that we'll be going over today. So we'll be looking at what assignment operators are and what logical operators are, and then short circuit evaluation. This will be our last set of operators. So let's look at assignment operators first. As you can probably tell by the name, the assignment operators are for assigning values. So let's look at the first assignment operator we'll be looking at, which is the equal sign. And this simply assigns a value. So for example, y equals 3. It just gives you a value. And let's say that whenever you're in a variable declaration, when we were assigning values to our variables, we use the equal sign. And it's something that we've used in math and every field where the equal sign assigns a value. And then remember that this equal sign can be used anywhere in the program. You can always change the value of a variable and change it later in the program. So let's say you create y as 3, but later you want to make it 2. So you could write y equals 2, and then the value of y will be 2. Now let's look at another assignment operator, which you probably aren't familiar with yet, which is the plus equals operator. And what this does is it adds on to the existing value. So let's look at an example. Y plus equals 3. Now that's the same thing as writing y equals y plus 3. So what you're doing is you're taking the y value, or whatever value, existing value, and you're adding on 3 in this case onto that value. So y equals y plus 3 is the same thing as y plus equals 3. And it's something that, it doesn't seem like something necessary, but it can make your life a lot easier as a programmer, and it's often used when you want to add on to a value and increase it. So let's also look at minus equals, which similarly to add equals is just subtracting from the existing value. So y minus equals 3 would be the same thing as y equals y minus 3. Next, let's look at asterisk equals, which is, as we know, the asterisk stands for multiplication. So you can probably infer by now that you'll be multiplying an existing value. So y multiplied equal to 3 is the same thing as y equals y times 3. So you're just basically making the statement shorter with these assignment operators. And then we have the slash equals, which, as you know, the slash stands for division, and then you'll be dividing from the existing value. So y slash equals 3 is the same thing as y equals y divided by 3. And the last assignment operator we'll be looking at is the mod equals, which is getting the remainder from an existing value. So for example, y mod equals 3 is the same thing as y equals y mod 3. Now don't forget that mod stands for remainder, and it's something that we'll be using a lot. And the purpose of these assignment operators, besides the addition one, is that they aren't actually required. I mean, you can live with writing y equals y mod 3, but the purpose of them is to make the life easier for the programmer and to make your programs a lot more clearer. Next, let's take a look at logical operators. So these are used for complex conditions. Now if you remember, a condition is a Boolean expression that evaluates to true or false, and a complex condition is a condition with multiple or a couple of conditions. So a condition is kind of like a compound. A complex condition is a compound condition, so it has multiple conditions in it. So let's look at the and condition, which is a conditional and. That's what it's known as, the conditional and operator, and that means that both expressions have to be true for the condition to evaluate, the complex condition to evaluate as true. So for example, x is greater than 2 and y is less than 5. So x has to be greater than 2 and y has to be less than 5 in order for the complex condition to return a value of true. Let's look at a quick table which tells us when a complex condition with the and conditional will return true and when it will return false. So the only way that you can get a true value returned when using the conditional and is when both values are true. If even one of them is false, it automatically determines it to be false. So if you look at it probability wise, you have a 75% chance of getting false and a 25% chance of getting true. Next, let's look at the conditional OR operator, which is just two parallel lines going vertically, and only one of these two has to be true. So as you can tell, we have AND, which means both, and OR means either one. So let's look at an example. So so this is also used for complex conditionals, and x is greater than 2 or y is less than 5. So as you know, if let's say x is greater than 2 is false. But that's alright. If x less than 5 is true, then the statement will be evaluate to be true. And the only way that such a statement can evaluate to false is when both conditions that are part of the complex condition are both false. So let's look at the table. So true will evaluate to false, false will evaluate to true, false true will evaluate to true, and only false will evaluate to false. So as we know that it seems like the AND and OR operators are complete opposites of each other. So for the AND operator, the only way to get true was true and true, and for the OR operator, the only way to get false is false and false. Next, let's look at the logical NOT operator, which is simply an exclamation mark. So if you remember when we were looking earlier at the equality operators earlier in the course, remember we saw exclamation mark equals, which represents not equal to. And we know that in Java, the exclamation mark represents not, or basically the opposite. So for this one, if you were to have not true, then it would be false, and if it's not false, then it's true. So the thing is, there's only true and false. So if it's not true, then it has to be false, and if it's not false, it has to be true. And then let's look at an example. So we have an exclamation mark outside of a condition, which is x is greater than 2. So let's say that x is 3, so x is greater than 2. So we would get a true from that condition. And then we have exclamation mark true. So that would turn that true into a false. And similarly, let's say that x is 1. So if x is 1, then it's not greater than 2, so then it would evaluate to false. And then because of the exclamation mark, which represents not, it would be not false, also known as true. And the last thing that we'll be going over for this lecture is short circuit evaluation. So what short circuit evaluation is let's take an example such as the conditional AND operator, which is two AND signs. And you can see that what if we have a false condition as the first condition? So there's two conditions in a conditional AND operator with a conditional AND operator, and we know that if both of them aren't true, it has to evaluate to false. So if the first condition part of the entire complex condition is false, then the computer automatically knows that the computer automatically knows that the complex condition will evaluate to be false, and that's why it doesn't even bother to look at the other condition, the second condition, which could be true or false, because it has no impact. And this is something that's known as short circuit evaluation, because think of this as a circuit, the computer going through the entire condition, and it's taking the shorter route because it already knows the result. And similarly with the conditional OR operator, if we only need one true condition for it to evaluate to true. So once you have one true condition, no matter what the second condition is, it will always evaluate to true. So then if the first condition is true, then the computer automatically knows that the value of this conditional operator will be true. So conditional OR operator will be true. So in that case, it automatically skips the second condition, which could be true or false, and returns true because it knows that it has to be true. Now, you may be wondering, what's the problem with that? It's just making the program faster. But the important thing to notice is that sometimes the second condition could be something like x plus plus is greater than 1. So even if it's true or false, it doesn't matter. We want to have the x plus plus operation occur because that's essential to the rest of our program. Or something's happening in the second condition that we need for the rest of the program, and there's some operation occurring. So the solution to that is having a single AND symbol and a single vertical line. So each one represents the and the or, and they both have this exact same function as the and the conditional and the conditional or. They both evaluate complex conditions, true, and they are both they both have the same requirements, but the difference is they have no short circuit evaluation. So if you were to put, let's say, in a and conditional and situation, if you put a false condition with a single and a true condition, it would still look at both conditions even if the first condition was false. And same thing for the single vertical line. So that's all. That's why short circuit evaluation is sometimes a problem for programs, and these are the two symbols that are used to avoid it. And keep in mind that the solution, and I've gone over short circuit evaluation, which is a part of the AP Computer Science exam, but these two symbols I've gone over, the single and single vertical line, are not part of it. So to recap, we looked at short circuit evaluation, and we looked at logical operators, and we also looked at assignment operators, and we saw that assignment operators make our lives easier by making our statement shorter, and they also include the equals to sign. And then logical operators are the conditional and or, and they're used for complex conditions, and requires both conditions to be true, and or requires only one to be true, and the not operator is the opposite.